Hello, Algebra 2 students. This is Mrs. Banyan, and today we're going to be reviewing a lot of the concepts that you guys have learned about polynomials. So we're looking at big picture, we're putting a lot of these concepts together. So let's start with what we already know about polynomials. If a polynomial is in standard form, then the degree can be found as the highest exponent. If there is none, then we would assume that this x has a degree of 1. So from here, we can see if the degree is even or odd. Remember, for odd functions, my arrows are going in opposite directions, and for even functions, my arrows are going in the same direction. I can also take a look at the first number and see if it's positive or negative. This tells me if I have a positive or negative leading coefficient. If something is positive, then that means that the right arrow is going up, and if something is negative, then that means my right arrow is going down. So if I have a linear, odd, positive, then my function would look like this. If I have a quadratic, even, positive, then my graph would look like this. For a cubic, odd, negative, this is what the graph would look like. And for a quartic, even, negative, I'd have a graph like this. Now, the degree can also tell us the zeros of a polynomial. It can tell us how many zeros we should expect to see. Remember that a zero is a value for x where the function equals a value of 0. So it's saying, what do I plug in for x so that way my equation equals 0 or it results in a 0? What's the input so that way that the output is 0? Zeros also go by a bunch of other names. We've called them solutions or roots, and sometimes our x-intercepts. There are 3 different ways that we've learned how to find a 0 in a function. First of all, graphing. You just look for the x-intercepts. So on your x-axis, that's where your function equals 0. So -3, 0, 1, 0. This has 2 zeros, or solutions, at -3 and 1. Another way we learned how to find a 0 is by factoring, and then we would use the zero product property. So for instance, this equation has already been factored for us, and it's set equal to 0. So I would just set each of these equal to 0, and I'd get my solutions of x equals -4 and x equals +5. The last way that we learned was using the quadratic formula. We find a, b, and c, and we plug it in and simplify. Now, out of all of these different ways, I would say that graphing is by far the easiest. You just look at the graph and you see where it crosses your x-axis, and you've got your solutions. But we've learned that graphing doesn't always give us nice answers, and factoring doesn't always work either. The quadratic formula is the only method that will always work every single time. But you have to have a quadratic to give that to find your solutions for that. And the quadratic formula can help us no matter what types of solutions that we see. Now, if you look at all 3 of these graphs, you can see that these are all quadratics. They all have that U shape, so it's a parabola. So for every single one of these graphs, I would expect to see 2 solutions. Let's take a look at our first one. Our first one, we can obviously see that I have a solution at -2 and 3. Because I can see them on my graph, I would say that they are real. And because they're nice numbers, I would say that they are rational. For this quadratic, I can see my 2 solutions, so I have 2 real solutions. However, these are not nice decimals. Remember that in order for something to be rational, then it needs to either have a number that stops or a number that repeats. And this is not stopping or repeating, and it looks like it's rounded in Desmos, and so I would say that these are irrational. This last one, I know it's a quadratic, so it should have 2 solutions, but I'm not seeing anything cross the x-axis. So for this last one, we can assume that my 2 solutions are both going to be imaginary. So depending on what type of solutions you see on the graph, that will determine what types of solutions you will get as your final answer. Lastly, let's just take a look at an example, and you guys can test your knowledge to see how much you know about this graph. I'll give you a few seconds, and I want you to think about everything that you can tell me about this graph. Okay, let's go over a few things. First thing I notice is that both of my arrows are going in the same direction, which means that I have an even degree. Because the shape of this, it looks like it's not a quadratic, so it's probably a quartic, so it's a degree of 4. I also notice that my right arrow is going up, which means that it's a positive leading coefficient. Since it is a degree of 4, I should have 4 zeros, or 4 solutions. Looking at my graph, it looks like I only see 2 places where it crosses, so I've got a real solution at negative 1.5 and a real solution at positive 2. That must mean that my other 2 solutions would be imaginary. So this is just a kind of a broad overview of everything that we've learned. We're going to be looking at some more big picture things over this week. Good luck on the rest of your week being all remote, and I will see you guys later. Bye.